Good morning. Myself, Dr. P.D. Sarokma, Professor and Head, Department of Automobile Engineering, Hindustan Institute of Technology, Coimbatore. So, welcome to my lecture on Engineering Thermodynamics. So, in this, we are going to see first unit. So, this is based on the Anna University, Chennai syllabus. So, main objective of thermodynamics, students can understand fundamental of thermodynamics and to perform thermal analysis on their behavior and performance. So based on this objective, so each unit we have some course outcome. Outcome 1 based on the first unit, that is we are going to apply the first law of thermodynamics for simple open and closed system and a steady state and unsteady state condition. Based on second unit, we are going to apply second law of thermodynamics for open and closed system and calculate the entropy and availability. In third unit, that is CO3, apply ranking cycle in steam power plant and compare few cycle improvement methods. Based on the course outcome 4, we have to derive the thermodynamic relation of ideal gas and real gases. The last CO5 will be the properties of gas mixture and moisture air. Using the psychrometry chart, we are going to study the process of the psychrometry. So nearly 75 hours, each hour having 9 hour, 3 hour, 6 hour tutorial hour. So first unit is covered with basic concepts and first law of thermodynamics. So this is syllabus. We will go one by one during our forthcoming lectures. So this is third unit, property of fused substance and steam power cycle. Fourth unit comprising of ideal and real gases and thermodynamic relationship. Fifth unit consists of gas mixture and psychrometry. So there are good books are available to refer. Few textbooks referred by Anna University, that is Raj Butt, a textbook of engineering thermodynamics, and also Sengel and also thermodynamics engineering. So the Sengel book having lot of application oriented concepts, and as well they explain detailed what is fundamental, how it is applicable to the engineering applications. And also PK Naak also is a very good book, one can refer those book also. So these are the textbook as well as reference book by the particular subject. So mainly applications. So if you take thermodynamics, mostly in steam power plant. If you take refrigeration systems, air conditioning systems, car and trucks and buses transport systems, heat pumps, fuel cells, even computers, and many more. There are a lot of applications where the heat and work and energy will be involved. You can apply this thermodynamics fundamental relationship and applications. So what is thermodynamics? Therm and dynamics. Therm means heat. It is a Greek word. From that, therm means heat. Dynamic means force or power, which is most descriptive of the all effort to convert heat into power. It is science which deals about the relationship between work and power and subsequent characteristics of the systems within equilibrium state. It is science of energy and energy transformation. Whatever may be, you can define. These are the main. The engineer objective is studying thermodynamics is the most often the relation analysis of or design of devices such as refrigerator, computer, nuclear power plant, many more. So simply, already I told you, therm means heat or warm. It is a Greek word. Dynamics means force or power. Okay, force or power. This force related to motion also. The motion of the atom will create the heat. What is temperature? Hotness or measurement of heatness is nothing but temperature. So this is a definition of the thermodynamics. It's a science which deals with the relationship among the heat, work and properties of the system which can be in equilibrium, and it describes the system and changes in the physical property of the system. What is the property? We'll see property one by one in upcoming slides. Okay, so here property means it may be pressure, it may be temperature, it may be volume. If you take ice in solid state at 0 degree Celsius, it having some property, that is a pressure 1, temperature 1 and volume 1. If you heating the particular ice, solid ice, it will get melt. It will reach 100 degrees Celsius. The complete ice will be converted into water, into liquid state. So here the pressure, temperature and volume will be changed. This is property state 1, state 2. Then again you are heating after 100 degrees Celsius, the liquid, that is the water, gets vaporized. So again it changes the state. Okay, and there also the property will be changed. The pressure, temperature and volume will be changed. So this relationship is the best example for the thermodynamics. Then we are coming to system, surrounding and boundary. What is system? Simple meaning is finite quantity of matter or prescribed region of space. தமிழ்ல சொல்லணும்னா வரையறுக்கப்பட்ட ஏரியா. Okay, system. What is surrounding? The space and matter external to the thermodynamic system. That is, other than the system, it is called surrounding. And what is the boundary? It is an imaginary space which separates a system from its surrounding. It may be a real one. If you take wall, it may be a screen, it may be anything, imaginary wall. So these are the systems surrounding boundary. Okay, so best example here, defining the system boundary will specify those interaction between systems and surrounding. If you take, so this is system, this is called as a system. It comprises of tank, air compressor, those things. So this air is coming from atmosphere, so it is interact with system, some mass interaction is taking place. So this closed confined region is called system, this is called surrounding. This imaginary surface or boundary is called boundary. It's also called as control surface. This portion is also called as control volume. So there are 3 types of systems are available. One is an open system, other one is a closed system and isolated system. Then what is open system? A system which can exchange energy as well as mass between the surrounding, it is called open system. If you take this cistern cylinder arrangement with closed wall condition, okay, so only mass cannot be exchanged, only energy can transfer to the system with surrounding through this boundary, through this wall. So this condition is called closed system. If any one of these wall, either inlet wall or exhaust wall, will be open, that condition you can transfer the mass with the surrounding. Then here the mass also transfer, energy also transfer. This condition is called open system. Okay, I will tell you once again. The open system means the system and surrounding exchange both energy and mass, then it is called open system. Cylinder piston arrangement with wall opening, it is called as open system. Then what about closed system? There's no mass transfer, only energy can cross the boundary. So the same piston cylinder arrangement, if both walls will be closed, then only energy can cross the boundary. So that system is called as closed system. Then one more will be isolated system. If you keep the hot coffee in thermal flask, there is no transfer of mass or energy. Neither mass nor energy That system is called isolated system. If you take entire universe, is called isolated system. Okay, so these are the three types of systems: open system, closed system, isolated system. You can make it the questions like what is system, what are the types of system in 2 marks. So whatever I tell you, know same thing in we tabulated. So open system, it is a control volume. Here this work transfer is taking place, heat transfer is taking place, mass also transfer. In case of closed system, only work and heat will be, that is energy will be transferred, no mass transfer. In case of isolated system, no mass, no heat, no air work can exchange the system and surroundings. Then we'll move into the continuum. What is continuum? The matter is made up of atoms that are widely spaced in the gas phase. It is convenient to consider the atomic nature in the substance and view as it is a continuous homogeneous matter with no holes in the space is called continuum. If you take any gases, the molecules are spaced widely. In between the molecules, there is a hole is present. If you omit this hole, you consider as the whole only atom with homogeneous nature, it is called as continuum. Clear? Is it clear? Okay, fine. So then we will move into macroscopic and microscopic approach. Then what is macroscopic approach? If you consider anything in large scale properties, if you take as a whole, consist of all atoms as a whole, that is called macroscopic approach. It is also called as a classical approach. That thermodynamics is called classical thermodynamics. It consists of less variable requires to define this particular approach. Okay. In case of microscopic approach, you can study level, molecular level behavior is constant. If you take chemical, best example is chemical reactions. So if you have some chemical formula with respect to atom, that is molecular level, it is also called as a statistical approach, and also it is called as statistical thermodynamics. Here to define this, you need more variable, even pressure, momentum, magnetic flux transfer, those things very important. It is a complicated one. But in case of thermodynamic systems, we are going to approach only macroscopic approach. Okay, these are the two main classification of macroscopic and microscopic approach. So best example, if you see this from this diagram, this is a potato having lot of atoms. This is a bulk material. Here this, if you consider individual some few molecules, it is called statistical approach. Okay, microscopy, atoms and molecules and molecular interaction. But in case of macroscopy, we are considered the bulk material, entire potato's temperature, what will be the pressure. Okay, that is called classical thermodynamics. Clear?